THC and CBD. I mean, they're two molecules from the exact same plant, yet somehow they've become household names across the globe for completely different reasons, right? One is obviously famous for producing that classic cannabis high, and the other? Well, it's pretty much marketed everywhere as this calming, therapeutic, entirely non-intoxicating miracle compound. But honestly, despite the endless sea of products, the flashy ads, and some very loud opinions out there, there is just a massive amount of misunderstanding surrounding these two. So today, in this explainer, we're going on a journey to separate the facts from the fiction. We're going to look strictly at what the actual science says.
Okay, let's dive into this. When you actually look past all that marketing noise and the really bold claims printed on product labels, you kind of have to ask yourself this core question. Are THC and CBD true opposites? Like, does one just cancel out the other? Or is their relationship far more intricate than that? Well, by the end of this explainer, you're going to understand exactly how these compounds really interact with your biology. So, here's our roadmap for today. First, we'll look at the roots of cannabis. Then we'll break down the endocannabinoid system, how THC works, what CBD actually does, debunk a few common myths, and finally, look at the entourage effect. All right, let's kick things off with part one, the roots of cannabis. And while the plant itself has well over 100 different cannabinoids, we're strictly focusing on the two most studied ones today. Now, what's really fascinating here is that despite having wildly different effects, our two main stars shared the exact same biological origin story. Inside the plant, the whole process kicks off with a precursor molecule called CBGA. Then, as the plant matures, natural enzymes convert that CBGA into acidic forms, specifically THCA and CBDA. But wait, here's the catch. They aren't actually active yet. If you were to just, say, eat a raw cannabis plant, you absolutely wouldn't get high. You'd basically just be eating a weird, incredibly bitter salad. It actually requires heat, whether that's through smoking, vaporizing, or cooking, to unlock them and convert those raw acids into the active THC and CBD that we're so familiar with. Moving right along to part two, the endocannabinoid system explained. This is where we get into the biological hardware. Because really, to understand how these plant molecules do anything at all, we've got to look at the system that's already sitting inside of you. This vast network, known as the endocannabinoid system, is constantly working behind the scenes in your body to regulate your mood, your appetite, sleep, pain perception, immune response, memory, and even stress. It's basically the ultimate command center for keeping your body in balance, or homeostasis. But the absolute crucial point here is how this system is structured physically. It primarily relies on two types of receptors. CB1 receptors are heavily concentrated right up in your brain and your central nervous system. CB2 receptors, on the flip side, are found mostly throughout your immune system and your peripheral tissues. And honestly, the physical location of these receptors is the exact reason why THC and CBD end up making you feel so drastically different.
Which brings us to part three, how THC actually works. Let's look at the heavy hitter. So, THC is the primary intoxicating molecule in the plant. When it enters your body, it behaves a lot like a key fitting perfectly into a lock. Specifically, it directly mimics our body's natural endocannabinoids and binds really tightly to those CB1 receptors up in the brain. And because it binds so strongly, it kicks off a loud chain reaction. You get euphoria, altered perception, intense appetite stimulation, hello munchies, and deep relaxation. But it is a bit of a double-edged sword, right? Because for some people, that intense CB1 binding triggers anxiety or paranoia. It literally all comes down to the dose, your personal tolerance, and your unique genetics. Now let's pivot to part four, what CBD really does. And what's really interesting about this next part is just how entirely different its mechanism is compared to THC. Think about it like this. If THC is a key that fits perfectly into that CB1 lock, CBD is playing a completely different game altogether. CBD has almost zero direct binding affinity for those CB1 receptors in the brain. Because it essentially ignores CB1, you don't get that traditional high. But please, do not mistake non-intoxicating for inactive. CBD is highly active across multiple other biological systems. It interacts with serotonin receptors for mood, vanilloid receptors for pain, adenosine receptors for sleep, and a whole bunch of inflammatory pathways. It's really more of a quiet, busy worker, operating behind the scenes. All right, moving into part five, debunking common cannabis myths. Time to clear up some of the noise using the science we just covered.
Now that we understand the actual biological hardware, let's dismantle some massive misconceptions. You'll constantly hear marketers out there claim that CBD is non-psychoactive. Well, yes, it's non-intoxicating, but a psychoactive substance is simply defined as one that affects the brain or mental processes. So because CBD actively influences things like mood and stress through systems like serotonin, scientifically speaking, it is still psychoactive. It just doesn't get you high. See, accuracy really matters here. And that brings us to another incredibly common myth. Does CBD completely cancel out THC? You hear people talk about CBD all the time, as if it's just a simple off switch you can hit if you happen to get a little too high from THC. Let's look at the reality.
The truth is, it's a much more complex equation. CBD doesn't just flip a magical THC off switch. While research absolutely suggests that CBD can soften some of the undesirable effects of THC, like anxiety or paranoia, it relies on some highly variable factors. Like, what is the exact ratio of THC to CBD? What was the dosage? What is your specific individual biology? And what was the exact timing of consumption? In some cases, sure, CBD tempers the high, but in others, its impact is pretty microscopic. It's a complex modulator. It's definitely not a magic eraser.
Now, when we synthesize the medical applications side by side, you can really start to visually see the distinct therapeutic lanes of each compound. Researchers are heavily looking at THC for things like chronic pain, appetite stimulation, nausea reduction, and muscle spasticity. Meanwhile, CBD has generated tremendous interest. I mean, it even has an FDA-approved medication for rare forms of epilepsy, alongside ongoing research into anxiety disorders, inflammatory conditions, and neurodegenerative diseases. Neither compound is inherently superior to the other. Their medical value entirely depends on the biological outcome you're aiming for. And quite frankly, the clinical science is still working overtime to catch up with the immense public enthusiasm for both of them.
Let's move to part 6 and see how this builds into the future of the science, the entourage effect. This is where things get really cool.
We are finally moving beyond just looking at these isolated molecules in a vacuum. Enter the entourage effect. This is the fascinating theory that cannabinoids and terpenes actually work together synergistically, producing effects that are entirely different from just taking isolated compounds on their own. Researchers are finding that a full-spectrum extract or different cultivars, whether they're THC dominant, CBD dominant, or balanced, highlight the plant's incredible chemical synergy. Basically, they're finding out that the real magic might just be in the whole plant working together. Which leaves us right here. For decades, the debate has been entirely binary, THC versus CBD, high versus non-high. But as you've seen, the science actually paints a beautifully nuanced picture. These compounds share a common origin, they interact with our bodies in drastically different ways, and ultimately, they might just be at their most powerful when they're working in tandem. So perhaps the most important question we should be asking isn't which molecule is better, but how does this complex symphony of compounds work together to create the unique effects that have fascinated humanity for thousands of years? Thanks for joining me on this explainer, and keep questioning the science.